Hello everyone, today we are going to study KMP algorithm. So KMP algorithm is basically called Knuth-Morris-Pratt, named after the three scientists that coined this algorithm. This algorithm helps you find all occurrences of a pattern in a string, and it does it very efficiently. So today we will be deep diving in KMP and we will try to understand how this algorithm works. So let's get started. So let's say that you are given a string AB, 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 and let's say you are given a pattern A, B, A. So how would you typically search this, right? What would be a common algorithm? So common algorithm would be that have a pointer or a iterator at the first character of the string and another iterator at the first iterator of the pattern. Now both iterators are at the first position of the string and pattern, and now we check if they are same, then we go forward, and the moment we see that they are exactly same, then we get a match. So the idea here is that for all the substrings of size 3 in str, you will repeat this. So you will do it for this, you will then do it for this substring, this substring, this substring, and so on and so forth. So like you can see, in a string of size n, and if the pattern is of size m, how many such substrings can be there? For example, in this you can see that for AB, 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 one substring is ABA, which matches the pattern ABA. Another substring is BAB, which won't match. Then is another ABA, right? Then again BAB. So how many such substrings will be there? So it's not very difficult maths. As you can see, this is 1, 2, 3, 4, 5, 6, 7, and 8. 8 such substrings are there. What is the size of this string? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the formula is that if when n was 10, m was 3, then the number of valid substrings will be n minus m plus 1, which in this case was 8. So for each of these substring, you will try to, all of these substrings will be of size m, and you will match this substring with the pattern, and then you will know whether they match or they don't match. So how much time does it take to compare one substring from the pattern if they are of same size? Order of m. How many such substrings are there? N minus m plus 1. So this turns out to be proportional to n times m, right? So let's do a simple dry run, right? Let's take a very small example of str pattern. So add another AB here. Let's make this ABA. So we start from here. A and A match. So we go forward. In both the strings, B and B match. Again A and A match. Now we get a perfect match. When the perfect match is done, then you see that we have to go back, right? Let's say that the first iterator is I and the second iterator is J. So currently I is at equal to 2, J is at equal to 2, but now when you get a match, I go all the way back to I equal to 1. Okay. And why do we do that? Because we have to stop at each substring. So it stops here. And where will J go? J will go all the way back to 0. And why do we do this? Because each substring has to be matched completely with the pattern, right? So you have to reset J to 0, and because earlier at I equal to 0, that substring you had checked, now you have to check the substring at I equal to 1. So again you will do B and A don't match. So now what do? Now we keep j, since j is at 0, so we don't change anything here. I becomes equal to 2. Now I is pointing at this way. Again we will match A and A matches, B and B matches, next A and A matches. Now we again get a match. Now what happens? Again I goes all the way back to, because I at I equal to 2 you had evaluated. Now you will evaluate at I equal to 3. And j goes, j, you had seen that j had gone all the way to 0, 1 and 2. But now again it will come back to 0, right? So both I and j are going back, right? So like I is coming front, then again it is going back, then again it is going front, then again it is coming back, then again it is coming front, then again it is going back. Similarly, j is going all the way to front and then all the way to back. Because of this movement, the order of n times m time complexity is coming. So what KMP did? KMP thought that can I make sure that I always moves forward, right? Let me get rid of these. So what KMP said, can I make sure that my I or the iterator at the string never comes back? I don't care about the iterator on my pattern, but my string's iterator should never come back. Can I assure that? So let's see if we can do that or not. When we get A, B, A matched. Now next character ahead is B. But right now we are at A and we have gotten that, okay, it is the exact match. But what next, right? Now, as I said, I is at 2, j is at 2, and I can't go back. So I has to go to I equal to 3. But what happens at this B? Now KMP said, okay, forget about I will move forward, chapter closed. Think where your j should go. Okay. So now think this carefully, right? Your j is currently here. When I is at 2, j is at also 2. Now when I comes to 3, okay, then where should my j go? That's the simple question. Okay, where should j go? Should j go all the way back to A? If it goes all the way back to A, do we miss any match that can happen? Let's see. If I go all the way back to A, then A and B will not match, right? And you can see that we will miss one match, right? This we detected, but we are definitely going to miss this match, right? If we take j all the way back to 0. So where should my j go? So answer here is, if you forget the y, you can clearly see that j should go to 1, because the moment it goes to 1, this b and this b match, this a and this a match, and you get next match also. Now same question when j is at this position, right? 0, 1, 2, 3, 4, 5. Again when I is equal to 5, again same question, right? When I was at 4, j was at 2, right? At this position, they both matched. So when I was at 4, let us erase old things. So when I was equal to 4, j was equal to 2, and now I want to make my I equal to 5. At this position, same question, where should my j go now? Again we can see if we take to A, then A will not match B, but if we take j equal to B or j equal to 1, then B matches B, A matches A, and it keeps repeating. So what is so special about this position j equal to 1 in this case, right? Now you carefully observe this. So KMP said that, see, this is special about j equal to 1 here, that every time resetting it to j equal to 1, you keep getting matches after matches after matches, and you don't miss any match. And the answer is that in this string, we tried to find what prefix is also the suffix. Okay, so we can see that string A is a prefix, which is also a suffix of this string, isn't it? Right? What does that mean? That simply means that when you match ABA, then of course each characters are matched. But because prefix and suffix are same, okay, listen this carefully, then this is obvious that the prefix matched the prefix of this and the suffix matched the suffix of this because it was an exact match. But it also means that the suffix matched the prefix here also, right? This A also matches this A also matches this A. Hence, when the next time B comes, right, then instead of taking the pointer all the way back to A, we do not take it all the way back to A because we know this A and this A have matched because the prefix is equal to suffix. Okay, this A and this A match, both the suffixes match, and the suffix is equal to the prefix. So this suffix matches this prefix. So what is the next character that you will compare? The character right next to the prefix, which is B, and that was the special thing about B. Okay, let's do a dry run again in this example. So till here brute force and KMP is same, but when B comes, then we take J back to here, B and B match, A and A match. Again when B comes, then we again take J back to this position, again B and B match, A and A match, and it keeps going forward. So KMP concluded that finding out the length of prefix and the length of suffix, which is same, is very, very crucial in string matching algorithms. Okay, let us take another example and understand this. Okay, so the pattern is ABAB and the string is ABAB. So now let us see here what prefix is same as suffix. We can see that AB is equal to AB, and there is no bigger prefix, right? Like if we take this prefix ABA, then there is no suffix AB. This is not true. So here also answer is 2. Previous case answer was 1. Here answer is 2, that length equal to 2 prefix is same as the suffix. Now when a mismatch happens after exact match, in the previous example when length was 1, you moved the iterator to 1. Here where will you move? Here when the I comes and you want to compare this A, then you take the J back to what position? Do you take it back all the way to the starting point, B or A? Answer is again simple, right next to the prefix. So this is the prefix, so right next this A. So here you get exact match. Now when this A comes, you take J here. Now this A and this A match, this B and this B match, this is another match number 2. Now when we come to this A, again J is at the end, 0, 1, 2, 3, right? J has reached its end. Now I moves one step forward. Now where do you take J back? Answer is again the magic number, J equal to 2. So again J equal to 2, this and this match. Again we get another match. Again we will get another match, and we'll keep getting matches every time J is reset to 2. And why 2? Because 2 is the length of prefix, which is equal to suffix. This is the plain and simple idea behind KMP. Okay. Now KMP is a little bit more nuanced. Like you run, this is called basically checking what prefix is same as the suffix is called LPS, longest prefix, suffix. Okay, and how it is calculated? Let's say you are given a pattern AB AB. So at each substring of it we check this. Okay, so understand this properly. So at I equal to 0, okay, so basically this is an array. We populate a LPS array. At I equal to 0, you check in this substring what is the suffix that is equal to prefix. We always initialize it with 0. Okay, the whole prefix and suffix will always match, so that is never taken into consideration. Now at I equal to 1, which is this AB, right? Is there a suffix which is equal to prefix? No. So again we write 0. Now at ABA, is there a suffix which is equal to prefix? Yes. And answer is 1. A and A, right? And now at this B, is there a suffix which is equal to prefix? Yes. Answer is 2. So this is called LPS array. And we use this LPS array to figure out where our J will go. Okay, let's see how. Let's say that you are given a string A, B, A, C, A, B, A, B, A, B, X, A, B. Okay, and the pattern is what we have already computed, A, B, A, B, whose LPS is 0, 0, 1, 2. So the algorithm says that, okay, start from I equal to 0 and J set here, J equal to 0. Both match. Good. Increment both the pointers. B and B match. A and A match. And C and B do not match. So when C and B do not match, firstly I will never go back. I stays there. And we try to figure out, okay, C and B don't match, where can my J go, such that we do not miss any future matches, and we want to bring J to the correct position. So the algorithm says that in the LPS array, go one position back. Okay, so J is at B, so go to whatever reading is one position back, which is 1. Okay, go to LPS of J minus 1 and set J equal to LPS of J minus 1. So it says it makes J equal to 1. So it says, okay, match with this B. Match this C with this B. Why did it say? Let us understand. Let us understand this properly. So when you had ABAC and you had ABAB, then a perfect match happened till here. In this string, is there a suffix which is equal to prefix? Yes, of length 1, A and A. So now when you move to C and this moves to B and there is a mismatch, do we take it all the way back to A? No, we firstly we know that this A and this A are same and there is a prefix which is equal to suffix, so this A and this A is also same. So if this C did not match this B, please match it with this B, because the A of the prefix and the suffix here match. So match the right next character to the prefix with the next character, which is C. So this B and this C also don't match. When again mismatch happens, then again we say take J equal to LPS of J minus 1. What is LPS of J minus 1 now? Here mismatch happened, so J minus 1 is here. It says go to index number 0. And now again it will say, okay, now match with A. Does A and C match? Again it does not match. So at this moment we will say, okay, now there is no matching character. Increment your I. So now I becomes at AB, and again this keeps continuing. Okay, so this is the importance of prefix and suffix and the LPS array. Okay, and once you have a LPS array, whenever a mismatch happens or whenever you are done with an exact match, you need to relocate your J, and that is done via J equal to LPS of J minus 1. Simple and easy, right? So let's quickly write the pseudocode for this. So for creating the LPS array, since you need to populate an array, so you need to pass a vector or an array. So let's say you pass me a vector of integer LPS, okay, and you of course pass me a pattern P. Now, as I said, LPS of 0 is always 0, so you start with that. Int I equal to 1. LPS of 0 is equal to 0. Okay, see, this is a vector which has been passed, and I will prefer to pass it by reference. And I'm expecting that you have already initialized a vector and given to me. Okay. So int I equal to 1, LPS of 0 equal to 0. That's the first step. Then what do? We have another iterator equal to 0. Okay. And now while, okay, now while I is less than pattern dot length we do something, and that something is we basically check if pattern I is equal to pattern length. Okay, so basically what I am trying to do, at ith character, substring ending at I am trying to see at length equal to 0, is there a suffix which is also a prefix. Simple. If I do get it, then length goes plus plus, okay, LPS of I equal to length, and I also goes plus plus, okay. And if it does not match, then what do? J equal to j minus 1, but there is one small condition, because j equal to LPS of j minus 1 will go into infinite loop. So to avoid that, if there is no j here, basically length, if length is not equal to 0, then len is equal to LPS of else. If it is equal to 0, then what do? Then when length becomes 0, then we say LPS of I is equal to 0. Okay, and we also do I plus plus. Cool. And this while loop ends, and the method also ends. Simple. So when I is equal to length, basically pattern I equal to pattern length, then length plus plus, otherwise length is equal to length minus 1. So let's do a dry run on AB. Okay. You give me this array of size 4, LPS of 0 equal to 0, length is 0, I is at 1. So this is your I, this is your length. A and B do not match. So because A and B do not match, then, and length is at 0, so LPS I equal to 0, and I goes I plus plus. I goes here. Now is pattern I equal to pattern length? Yes. So what do? Length plus plus. So firstly length gets incremented. Length gets incremented. LPS of I is equal to length, which is at 1 now, and I also goes I plus plus. Now is B and B same next time? Yes, again same. So length goes length plus plus, so length becomes from 1 to 2. LPS I equal to length, this becomes equal to 2 and I plus plus. Now I is greater than the length, and this while loop will make it stop, and my LPS 0012 will be returned. Okay, so you know how to create LPS. Now let's solve KMP. Void KMP. KMP will take two strings, str, string pattern, and first thing it will do, it will say compute LPS. Okay, so let's name it compute LPS. Compute LPS. You will pass a vector. Vector's name we will keep LPS. We will create that vector. Don't worry. Pass the pattern. Vector of int LPS pattern dot length. So we created a vector equal to size of the pattern length, and we passed it in compute LPS. It will populate 0012 in our example sake, otherwise it will also populate it correctly and it will give me back. Okay, so compute LPS gives me the LPS array. Now we will take two iterators, like I said, one at start of string and one at start of the pattern, both equal to 0, while I is less than str dot length. I will never go back, so we will stop the moment I becomes equal to string length where we are searching, right? So now here it is also very similar. If string I is equal to string j. Okay, so this is basically AB. Sorry. AB. So the moment they are same, we keep, I plus plus j plus plus. When they are same, we keep incrementing them. And the moment, okay, leave some space here, we'll come back, I'll tell you why. And then the moment they are not same, right, then what do we do? Right? If they are not same, then what do we do? So, sorry, not strj here, pattern j, right? If a string I is equal to pattern j, then I plus plus j plus plus. So if they are equal, it is fine, but what if one of the characters was not equal? Then what do we do? So then our answer is very simple. We say that if j is not equal to 0, j is equal to LPS of j minus 1. Okay, j is equal to LPS of j minus 1, and that's where j is, restructured. And if j is equal to 0, then what do we do? So here, if j is equal to 0, then we simply say I plus plus. Okay, so this is what happens here. This is your while loop. So when we keep comparing them, right, one after the other, and the moment they are not equal, we do this, and that's it, right? There is one small catch. What is detection condition? When do we know that a match has happened? So this is where, okay, so if j is equal to pattern dot length, then a match has happened. You can print it, you can do whatever you want, but the most important thing here is where does j go, right? j, again j goes j equal to LPS of j minus 1, as we have already discussed. Okay, and we keep doing this until I reaches end of a string, and you see if match happens then I is incremented, if match does not happen then also I is incremented once j reaches equal to 0. Okay, so firstly j will try to restructure it somewhere in the pattern string, and if it never matches any character, the ith character in the string and the jth character in the pattern never match, then of course j will eventually become equal to 0 and I will be incremented. And that's why this algorithm always works. Let's do a dry run. Okay, so this is str, this is the pattern, of course this array is also there which we have already populated. Let us see. So we start with I and j, they both are equal, so I plus plus j plus plus. Good. Again I and j equal, again equal, again equal. And now after this, after this j plus plus happens, j becomes equal to pattern length. So here j says that go make j equal to LPS of j minus 1. So what is LPS of j minus 1? When j comes here, then it says go to position number 2. Position number 2 is this. So j comes here and I goes here. Now this a and this a is matched. Again they match. Again I plus plus j plus plus happens. J goes here. This b and this b again match. Again I plus plus j plus plus happens, and I reaches end of a string. We got two matches, one here and one here. Okay, so you could have printed that at this point somewhere. Okay, so this is all about KMP algorithm. Watch my next video where I solve a problem using KMP. You will understand it a little much better. Thanks for watching. Hope you understood KMP.